Hi, everybody. Let's do IXL 5th grade BB.4. Go to Learning, go to 5th grade, and then scroll down to BB.4, Find Missing Angles in Triangles, which is, you're going to see a very easy exercise. Right? What is the measure of the missing angle? So we have a triangle here. We know that one of the angles is 29 degrees. The other angle is 33 degrees. And we have to figure out what the measure of this missing angle is. Now, how are we going to do that? Well, there's one very important piece of information that we need to know, and it is on the reference pages. So it's going to be on page 13, where you'll find some interesting facts about triangles. So let's scroll down to page 13. Here we are, page 13. And specifically, we're just going to need this one piece of information right over here. The interior angles. Interior is just a fancy word for inside. So the angles on the inside of a triangle always add up to 180 degrees. So for example, we might have an equilateral triangle. That's a triangle where all of the angles and also all of the sides are equal. So in an equilateral triangle, each angle is 60 degrees, and 60 plus 60 plus 60 equals 180. Or we might have a triangle, let's say, that looks like this. One angle is 40 degrees, another angle, let's say, is 120 degrees, and then the third angle would have to be 20 degrees. And we see again 40 plus 120, that would be 160, plus 20 equals 180. So no matter what kind of triangle we have, could be equilateral, it could be just a general isosceles triangle or a right triangle or anything, it doesn't matter, an obtuse triangle, the interior angles always, always, always add up to 180 degrees. And actually, I want to prove that to you before we go into the IXL problems, which are really not hard at all. Over here, you see these two lines, 1, 2, you can see that these lines are parallel lines, meaning they're moving in the same exact direction. And then I have another line over here, and this line is cutting these two parallel lines. And a fancy word for that is a transversal. So a line that cuts two parallel lines is called a transversal. But one interesting thing that you'll notice about a transversal is that, let's say I wanted to look at this angle right over here and this angle right over here. These angles are on alternate sides of the transversal. One is on the right, the other one is on the left. And they're both in the interior of these parallel lines over here. So they're not on the outside over here. They're both on the inside in between the parallel lines. So these would be called alternate interior angles. So these two angles would be alternate or ulterior angles. You can see that both of these angles are a little bit obtuse, right? They're a little bit more than 90 degrees or a right angle. And these two angles over here, this one and this one, these two angles are also alternate interior angles. And you can see for these angles are both a little bit acute. They're both a little bit less than 90 degrees. And in fact, both of these angles are exactly equal to each other. They're not just both acute, they're both exactly the same. These two angles, which I drew in blue, are also exactly equal to each other. They're not just both obtuse angles. They are both obtuse angles, but more than that, they're exactly equal to each other. And in fact, you can convince yourself that if I take this line, no matter how I draw this line, so now I'm taking this line and drawing it this way, again, you can see that this angle over here got squeezed. It got even smaller than what it was before. But this angle here and this angle here, they both got squeezed in exactly the same way, and they're both still equal to each other. And these angles over here, they both got stretched out quite a bit. So they were obtuse before, now they're really obtuse, right? They're pretty big angles now, but they both got stretched in exactly the same way. So they're still equal to each other. So that's something interesting about alternate interior angles. They're always congruent. They're always equal to each other. Now, the IXL exercise that we're going to do is about triangles. What the heck did all of that have to do with triangles? Well, we're going to need this idea of alternate angles being equal to each other to prove that the angles of a triangle always add up to 180 degrees. So let me scroll down a little bit here. And oh my goodness, look at that. Oh, I have a triangle here, right? And let's say that let's call the angles of that triangle, let's call one of these angles A. Let's call another one of the angles B. And let's call the third angle C. And what we're going to try to do is we're going to try to figure out the sum of the angles A, B, and C. So we want to know what is A plus B plus C. I'll make that a little bit bigger. Right? That is equal to what? Can we figure it out? Remember, sum just means that we're going to add all of them up. So when I add up A and B and C, what do I get? Can I figure it out? Well, actually, we can figure it out. And the idea is to use these alternate interior angles right over here. All right. So what I'm going to do is I'm going to take a line that is parallel to the base of this triangle over here. Right. And I already created a line earlier before I started making the video. So you can see that this line right over here is parallel to the base of the triangle. Both lines are moving in exactly the same direction. So let's just put this, well, let's put this line right up here. Okay, so now, just like before, I have two lines which are parallel to each other. This line and this line are parallel to each other. And this line would be a transversal. So this is a line that it cuts, or it's intersecting these two parallel lines. And this line over here would also be a transversal. Now, what did we learn before about transversals? We learned that alternate interior angles of a transversal are equal to each other. So if this angle over here is equal to a degrees, then this angle over here must also be equal to a degrees, right? Because we said alternate interior angles are always equal to each other. But I can say the same thing about this angle over here. If this angle is c degrees, then this angle must also be c degrees. Now, why is it important for me to know that? It's important because I can see now that A plus B plus C makes a straight line right over here. Can you see that? This line right over here is a straight line. So if I start over here and I go through A and through B and through C, I just made a straight angle. This would be called 180 degrees is called a straight angle. And I know that it's 180 degrees because it made a straight line over here. So I know that A plus B plus C must be equal to 180 degrees. But A plus B plus C, A, B, and C, those are also exactly the angles that I have inside of the triangle. Right? So I just figured out that the sum of the angles of the triangle, which is A plus B plus C, must be equal to 180 degrees. And that reasoning that I just went through for this triangle, that applies to all different triangles. I didn't have to make a triangle that looks just like this. I could have made it an equilateral triangle or a right triangle. I could have made any triangle that I wanted to. And then if I just use that trick of putting a line over here, which is parallel to the base, then I would still be able to figure out that the angles A, B, and C must add up to 180 degrees, no matter what triangle I started with. Okay, so that's a little proof there. And now we can use that information to figure out the missing angle in any triangle. So if I have any triangle and I'm given two angles, I can figure out what that missing third angle must be equal to, right? So for example, in this question, I know that 29, which is this angle over here, plus 33, which is this angle over here, plus this question mark, is equal to 180 degrees. So what's the question mark? Well, 29 plus 33, that would be, what, 62? So 62 plus the question mark is equal to 180. So then I just subtract 62 from both sides. And we get here that the question mark, which I could have called x, but I'll just leave it as a question mark, is equal to 118, right? 118 degrees. And we can just check that. We can see that 118 plus 29 plus 33, when we add all of those up, we actually do. That would be 17 plus 3 is 20. And then 2 plus 1 is 3, plus 2 is 5, plus 3 is 8. Okay, good. So I did the math right. So yeah, when we add them all up, we get 180 degrees. Oh, no, that's not, yeah. So 118 is what I want to write, not 180. Okay? And all the other questions, I believe, are pretty much the same. So the bulk of this video is going to be really what you already watched, hopefully, that the proof that the angles must add up to 180 degrees. So the rest of it is just easy. It's the same thing. So if I want to know what this angle is, then I have to think to myself, well, 34 plus 90 plus, I'm going to call it x this time, equals 180, exactly like the last problem. So we get 124 plus x equals 180, and then subtract 124 from both sides, and we get x is equal to 56, right? And we can just check that. We have 90, let's say, plus 30. I'll start with the 90 plus 34 plus 56 is equal to 180. Yeah, so it works. So we're just figuring out the missing value that makes the sum equal to 180 degrees. Right? So in that case, it would be 56. So it's always, okay, this one would be the same thing. 81 plus 35 plus what equals 180. So really, all you have to do is, give you a quick way to do it. You could just do 81 plus 35. That would give you 116. And then just do 180 minus 116. That would be 164. And then just to check that you got the right answer, so this angle over here must be equal to 64 degrees. Again, just to check that, we can do 81 plus 35 plus 64, and 1 plus 5 plus 4, that would be 10, carry the 1. 1 plus 8 is 9, plus 3 is 12, plus 6 is 18. Okay, so yeah, we do get 180 degrees there. Am I going to get a question which is different? No, they're all pretty much the same. I'm going to jump a level here, and I think the only change is that I get words instead of pictures. So here I have, just in words, it's describing, something exactly like what we saw before. Two of the angles in a triangle measure 23 degrees and 141 degrees. What is the measure of the third angle? So again, all we really have to do is 141 plus 23, and that's going to give us 164. And then step 2, we're going to do 180 minus 164, and we get 16 there. And just to check our answer, if we do 23 plus 141, if I was subtracting, I would have to put the bigger number on top. But if we're adding, we don't have to. Plus 16. If we just add all of those up, 3 plus 1 is 4, plus 6 is 10. Carry the 1. 1 plus 2 is 3, plus 4 is 7, plus 1 is 8, and the 1 there. Yeah, so again, we get 180 degrees. Okay, so it's just what number added to these two would give us 180 degrees. That would be 16 for this one. And okay, again, it's the exact same thing. Okay, so as long as you know that the angles of a triangle must always add up to 180 degrees, then you know how to solve these problems. All right, reach out if you have any questions, and have a great day.